found it digging a hole 50 foot deep.
If I want to find the dinosaur bone, where should I go?
Wyoming. Yeah, Wyoming. Yep, south. All out on there is where you find the good dinosaur stuff. Our Southwest Adventist University has a dig out there. They'll actually let you go and dig. You don't get to keep what you find most of the time, but you can go out there and dig and find the bones.
Thank you. Okay. The same question. What do you like the most?
Oh, I like a little bit of everything, but I really like the rocks. They're not listening. I really like the rocks that have the something inside them. That's probably my favorite thing. I haven't found any of these, but I like the way they look.
Thank you so much. And what you gonna study today? What do you guys prepare for us today?
Starting with the Glacier honor.
Glacier honor.
Since we know that most of y'all went to a glacier, we figured that was a good one to start with.
Okay. So thank you so much. We appreciate to have you guys again, and you are very welcome.
Well, we appreciate it. I've got the,
Oh, you have it. Okay.
yeah, I've got
Thank
the
you.
lapel one. Does everybody have a worksheet? No. Does anybody have a worksheet? Okay. Okay. Hopefully we made enough copies for everybody. I'll start out with a prayer. Okay, has everybody had a worksheet? What's that? Yeah, write your name on your worksheet. Okay, let's start out with a prayer real quick. Let's bow our heads. Dear Father, thank you for being here with us today. Thank you for the love that you've shown us. And as we study about your nature, please help us to learn new things, to help us appreciate you more. Bless us and guide us and keep us safe. In your name, amen. Okay, so how many of you have got to see a glacier? Quite a few of y'all hadn't got to see a glacier, have you? It's a neat thing to see. I have never been to the glacier park where y'all have, but when we were in Yellowstone, we got to see glaciers. That particular glacier had a bunch of extinct grasshoppers in it that they were finding as it was thawing out. So I guess those were put there probably after the flood or something like that. It's kind of interesting. This is kind of a longer honor, but I think we can get through it all right. Let's see, let me grab the clicker for the PowerPoint. And we'll go ahead and get started. And maybe I won't put y'all to sleep since y'all just ate and are probably getting to where y'all want to relax and just kind of not really do much anything. So maybe we keep y'all awake. I think the batteries may have just died. There it goes. Okay. The light wouldn't come on it for some reason. I had to turn on and off several times. Yeah, you never know. Maybe y'all can see these. So what is a glacier? Any ideas? No, glacier's not on the water. That would be an iceberg. So where would a glacier be? If it's not in the water, it's got to be on land. Yep. And the other thing is, why is it important to study? You see, this is a glacier here. So a glacier is a large body of slowly moving ice. A glacier is made up of ice, snow, rock, and sediments. Some of the facts: they form over hundreds of years. They currently hold the Earth's largest supply of fresh water, and they cover about 10% of the Earth's surface. North America's largest glacier is Bering Glacier, and that's up in Alaska. It's 126 miles long and covers an area of more than 1,900 square miles. That's a big chunk of ice. I would love to go up to Alaska and see the ones as they're coming into the ocean, and you can see the big pieces calving and falling off. I don't think I'd want to get too close to them in a boat as big as they are, but it's something to see them as they fall off and see the waves that they make and things like that. Okay, so why do we study glaciers, and what is the study of glaciers? What's that? Glaciology is the study of glaciers. One of the reasons we want to study about glaciers is it tells us a lot about the climate, tells us what's going on. One thing they can do with glaciers is they can bore down into the glacier, and at different depths they can kind of figure out what kind of chemicals and different gases were in the atmosphere, or different particles and things like that, and they can kind of tell what was going on at different times with the Earth. If you have a bad volcano, they can detect a certain amount of the ash and stuff in that volcano. Because we don't realize that when you have a bad volcano, the ash gets put up in the atmosphere, and it can stay up in the atmosphere for a year or two before it comes back down the ground. And you'll get a certain percentage on something like this. Like when Yellowstone erupted, they found ash from Yellowstone all the way in Louisiana. So that's a long ways away. So you can find a lot of stuff going on to that. There'll be air bubbles that are inside of these glaciers, and they can test that air and find out how much carbon dioxide, how much oxygen and stuff was in the Earth's atmosphere at the time. So it gives a good record of things that's went on with the Earth over time. So that's one of the reasons you study it. Other things to learn more about ice, learn more how they move and different things like that. Okay. One of the things here is create a game, such as a matching game or board game, to where you can look at some of these different definitions. I'll let your directors decide if they want to do that. But for right now, we'll just go over these definitions and see if we can learn what some of them are. Okay, what's a crevasse or crevice? What would that be? This would be the crevice. Let's see if a crevice is a crack in the surface of the moving ice. It may be narrow or it may be really wide. And that doesn't look like a real deep crack. Some of those cracks can be 1,000 or more foot deep. So you want to be careful whenever you step over something like that, because if you got something 2 foot wide and 1,000 foot deep and you fall in it, it's not going to be easy for somebody to rescue you, although there's probably no need for them to rescue you if it's that deep, because you probably didn't make it when you hit the bottom. And I don't know, y'all know how ice is. It wouldn't feel too good to fall in something like that and have ice cut you all up. Something to me about getting cut with ice or something like that is a lot worse than a regular cut. Okay. So you can see here it's kind of showing how the ice, as it moves, gets cracks in different areas. It's not really nothing y'all need to do. Okay, some of these names are like from the Norwegian countries, and I know I'm going to murder the pronunciation of them. I'm going to say like a fern, but it's probably something different. It's cutting off some of my stuff. But that is the term for the snow that is being compressed enough to eliminate the air pockets in it. Because you know how snow, I've never been in real thick snow, but the snow that I've been around, it's kind of a little bit fluffy. It has air all in it. Well, you think about if you get 100 or 1,000 foot of snow on top of it, it packs that snow and turns it into ice, and it gets all the air out of it as it packs down. So that's the area right through there where it gets to the point to where there's no more air left in that snow and it turns into ice. You'll still get little air bubbles where they do the analysis, but it's not big stuff, so that the air is trapped in it instead of just being kind of free to where it can go in and out of it. That's some more stuff. Okay, glacial drift. What do you think glacial drift would be? What would drift make you think of? Movement. So that's not what you think, though. It's not the glacial moving, but they call the drift the actual deposits that it picks up as it's moving. If they could take an ice cube and rubbing it over the ground, when you pick it up, is it going to be clean? It's going to pick up grains of sand and all kind of stuff like that. Well, that's what this does. When we were out in Yellowstone, we went through an area where it had picked up rocks and boulders. Now, some of these boulders were the size of a house that it picked up, you know, but it'll pick up small things and large things as it goes through there. But that's what glacial drift is, you know, is it's the unsorted sediments and deposits, you know, that it gets. Okay, what's a glacial erratic? Any ideas? Okay. Well, this would be an erratic. You see, it broke off a piece of the boulder as it went through, or it picks one up, and it kind of gets caught up in the flow. But as the glacier melts and retreats back, it gets left out there. So that's it. It usually moves them. It doesn't always drop them, because you can imagine with that much ice, as it's moving, it's going to take it with it no matter what it does. It's got to melt or break off to deposit and leave the stuff. If not, it just carries it with it. And we're talking about forces that we can't stop. Imagine a 20-mile sheet of ice slowly moving. What are you going to do to stop that if it's 1,000 foot thick and a mile wide? It's going to do what it wants to do. And that doesn't matter if a big stone or something gets in his way that's the size of this church. It's going to eat it up and keep right on going. So these are rocks that's been deposited by the glacier. So that would be some of the erratics that got left. They can use different names for them according to where they've been deposited, but that's basically what they are. Okay, what would icefall be? Well, not necessarily. Did I? Oh. Maybe we'll pick it up. Give me a minute. That happens sometimes. I probably got it out of order. It's probably my fault, I'm sure. I appreciate it. Okay, icefall is the equivalent of glacial waterfall. You can see that it's coming over a steep grade, and it's fracturing as it's coming over that steep point, and then just all the ice is kind of falling down. It's still kind of moving, going down, but it's all broke up instead of in one sheet. Yes? No, they told me I missed it, so apparently I got out of order on it. I can probably tell you what it is real quick in case I completely skipped it. I mean, basically it's a lake that's in a glacier. Let me see. Or it's a lake created by a glacier that basically it carves it out. I've got pictures of them on here a little bit further. Glacial lake is a pool of standing water on, in, or under a glacier, or formed by a glacier near its terminus. So the terminus would be where it stops. So we'll get there in a minute. So here's a kettle lake. And a kettle lake forms when a glacier when glacial ice in an outwash plain melts into a depression. So basically, you've got a block of ice. The ice stays there. You know, maybe the glacier brings more stuff, or maybe you have a mud flow come by it or something, and then it surrounds the ice. Then the ice melts up underneath it, and the land up underneath it falls, and it creates a depression. So you can see there's two different ones here that they show. But basically, the ice creates a hole in the ground, and then when the ice melts, the dirt up above it drops in that hole, and it creates a lake. These can be small, or they can be really large. And y'all don't have to write all this stuff for word. Y'all can paraphrase it just so you know what it is. That's all that matters. How would you pronounce that one, Amy? Nev? I'm not from those countries, and I would not have a clue. It refers to the part of a glacier that is permanently covered with snow. So you see right here, this is permanently covered with snow. Now you get to thinking about, well, all of it's covered with snow. Well, not necessarily, because a lot of times as it melts, a lot of these lower areas especially, the snow will kind of melt off and you end up with just solid ice. So now if you want to do a good slide, that would probably be a good place to do it on that ice until you hit one of the crevices or something. Glaciers can be a very dangerous place just because of everything that's moving steady and different things. And you get, you know, imagine if you had a crevice, but you'd had a little bit of snow and you had a bridge of snow over top of it, and then you walked over it. You're going down. So I've seen a lot of people, when they do this, it's several people, and they will actually tie ropes to each other and get about 20 foot apart. And if you got 3 or 4 people, if one of you falls, hopefully the rest of you can keep you from falling and you don't drag all of you in. So it could be very dangerous with the way they work. I'm not even going to try to pronounce that. Okay, that'll work. So it's an arrangement of lakes in a linear series. I don't know how well you can see it on the slide, but you see you got a lake here, there's another lake here, there's another lake here, and there's another lake here. So basically, as that glacier was moving, it's a good chance it probably left lines of sediment because of different elevations in the bottom of that glacier or something, and it would just kind of push the dirt and the mud and everything along. But then you had a warmer time, and that glacier melted, so it left little dams in between here, and it allowed these lakes to form. So it's left by as it's retreating upstream. Okay, plucking. What would plucking be? Huh? I'd say we pluck a chicken before we eat him. In glacial terms, plucking is the process of moving glacial dislodging or lifting of rocks or boulders. So you see you got boulders and it kind of picks them up, but it kind of plucks them loose and takes them loose and gets them deposited inside the glacier. So it plucks them off the floor or a high point or something like that and moves them right on along with it. So it's plucking it up from the bedrock and carrying the deposit, and usually later dropping it somewhere else. So just think of plucking a rock up off the floor that the glacier's sliding on. A cirque. Cirque? I think that's called a cirque. I think they call that one. And it's just a jagged pinnacle or tower of ice on a glacier. That looks cool, but I don't think that's anywhere I want to try to play on top of. Because I bet about everything you try to grab up there, you're going to slip off of. And I've always heard when you're cold, bones don't break, they shatter. Okay, subglacial stream. I mean, that one's fairly self-explanatory. it implies a stream that flows underneath a glacier. So here you've got glaciers and you see the streams flowing out from underneath the glaciers. Because, I mean, you're going to have just the friction will make the glacier melt a little bit, or the warmth from the Earth's surface will make it melt a little bit. You're going to get a certain amount of water flowing out from underneath it, so it creates streams up under the glacier. So a tarn, that basically is a lake formed in a cirque. Well, a cirque is a bowl-shaped depression. Like this here would be the cirque, and this would be the tarn. We'll see some more pictures of cirques later. But basically, it's a lake formed in a cirque. Y'all should have learned all these terms before y'all went out and saw the glacier. Then y'all could have talked to everybody and made everybody think y'all was a glacier expert. Okay, so this would be a tarn. This would be the cirque that it's made, that it's formed into. Terminus, or they also call it a toe at a glacier, is the furthest, lowest margin of a glacier. Basically, it's the end of the glacier. It's where the glacier is terminating, where it's either breaking off or going into the sea, or it's melting and turning into water at the bottom of the valley or something like that. So if you just want to put the end of the glacier, that's fine. And you'll see a lot of these different terms all through here, you know, as we go on these things where they're labeling them. So how are glaciers formed? What do you think the steps are for a glacier to form? What's it have to start with? Snow or water, but you got to have snow. The snow falls a lot in one area and gets so thick that the snow on top of it presses the bottom and turns the snow into ice. Like I say, we're talking things that could be a couple of 1,000 foot thick, some of them. Usually not that much, several hundred, but they're thick. So once, like on a mountain or something, you get the buildup, well then that gets so heavy, gravity starts pulling it down into the valley. And it's going to move. It's not going to be like an avalanche or something. It's going to go very, very slow. And one of the reasons it goes so slow is you've got so many irregularities in the floor and in the sides. They're kind of locking it in, and it's slowly having to break and eat all that stuff away as it goes down. And the shape's steady changing, so it's getting jammed up and logged up as it's trying to go down, but it eventually makes it just because of the sheer weight. It tears whatever's off of it, whether it's solid rock, wood, or anything. If a house gets in the way, it's gone. So it doesn't matter. So where can a glacier be found on a map? Where would you expect to find it? More in the northern, or the southern and northern. I mean, we don't expect to see them on the equator, but here's where the most concentrations are. You can see they're not all in the poles like you would think. There are some. Would you expect to have glaciers through this area here? But you have a lot of high mountains. And when you have the higher elevations, you have the colder temperatures. So it can even be closer to the equator, but you still have the high altitude, which gives you the colder temperatures. Yep. They're all over the place. I mean, even looking here, you're getting down into areas that you would think would be hotter. But you're dealing probably in here with, I don't know exactly where they are, but you're probably in the Himalayas and some of those areas in there, so you're dealing with very high elevations. I mean, you can look in the areas right in here. I mean, the glaciers came down real low in the United States. There was a lot of them there at one time after the flood. So it's neat to get a map that shows where the glaciers were at one time versus where they are now. Because the Earth has heated up a lot since the time of the glaciers in the Ice Age after the flood. And it's still heating up. That's one reason we do have so much of the glaciers melting. It's been happening for the last 4,000 years. And it's probably going to keep happening. Okay, what are the two major types of glaciers and the subtypes of each? Can y'all think of types of glaciers? Did y'all know there were types of glaciers? Okay. You have an ice sheet glacier, you have an ice cap glacier, you have an ice shield or ice field glacier. So whenever you get in, here's some more different types of glaciers. You have a Piedmont, a cirque, you have one for a valley, or you have a continental shelf. Where might you have a continental shelf glacier? Maybe somewhere like Antarctica, where it's covering the whole continent just about. Although that wasn't on the map just then that much. But you have a bunch of different types. Let's see, I'm trying to see. They're showing Antarctica and they're showing Greenland. Never figured out why Greenland's called Greenland and Iceland's called Iceland. They need to reverse the names. Because Iceland's green and Greenland's ice.
I think that comes from World War.
Probably so. But it's just kind of weird. Although Iceland is known as the land of fire and ice because they have a lot of ice, but they have a lot of volcanic activity and stuff. Does everybody have something for this? Or can y'all read it? Yes. The first one? Let's see. Let me look here at the answer sheet so we get the official thing instead of what's on here. It may help. I probably ought to be keeping up with this. There's a lot of information to cover on this. Some of it's kind of neat. I know some of it I'll probably bore y'all to death with. Okay, 2 types of glaciers. So they're showing an alpine glacier. And they're showing the continental or the ice cap. They actually are not really, they're telling about what this is told here. You've got the cirque glaciers. The cirque glaciers are more up underneath the alpine glaciers. And also the Piedmont glaciers, the valley glaciers, they're more under the alpine glaciers. So I guess under the continental ones, you would have ice caps. And let's see if they tell another one. Continental and ice cap glaciers. So, yeah, the continental glaciers, they say, do not require mountains to form, where the alpine ones do. And they don't really give a whole lot on the continental ones. They just say that they're the types that are like in Greenland and Antarctica. So that's just kind of your different things. A lot of it's controlled by where it forms and some different things like that. So y'all should have extra paper on the back, and y'all can do this later, or we can take a minute to do it now. In a diagram of glaciers, label the following parts and how they work together to cause glacial movements. Okay, the accumulation zone is one of them. So you can see right here is the accumulation zone. Now, I'm sure you might get some down here, but when you get in these alpine type glaciers, a lot of times you'll get a lot more snowfall at the higher elevations than you will at the lower ones. So you have a lot more accumulation up at the top. And that creates a lot of pressure from the weight, and that's pushing down and trying to push it down in the valley. And then you have the abation zone. I was trying to find it on the picture here. Basically, it's the area of the glacier where loss of ice and snow exceeds the accumulation. So you can kind of see somewhere in this area, you start getting a lot less glacier and thickness and stuff like that. So as it's moving down, not only is it breaking up and losing by it turning into water up underneath it, but you also get melt on the top. So instead of it building up like it does in the accumulation zone, it starts getting less and less, and you start getting, a thinner and thinner glacier the further down you get toward the terminus or the end of the glacier. Let's see. And you have the equilibrium line. The equilibrium line is the area of the glacier between those two zones. So that would be similar to like this right in here. So from this way up, it's accumulating. From this way down, it's receding. Okay, has everybody got something for that? Okay, so explain how a glacier advances and retreats. How would a glacier advance? Gravity makes it advance for sure. And, you know, getting more snow on the top, adding more weight to it, like I say, gravity's pulling it down the hill is basically what it's doing. Because even on your continental shelf glaciers, most all of them are still moving because you got a little bit of elevation. They may not be going fast, but they're still normally all of them moving toward the ocean or something like that, or to a lower elevation. Okay, how about retreating? What would make it retreat? Melting. You know, right here they're showing it breaking off, calving off. So, you know, you could have warmer temperatures, making it retreat. You could have the ground up underneath it, washing it away. You could have it's there at the ocean, and the ocean even eroding the bank up underneath it, and it is breaking off, falling into the ocean. In most cases, it's melting is what's causing it. You know, a lot of times it may not necessarily be retreating, because what it's doing is it's pushing it over the hill into the water, and it's breaking off and flowing into the water. So it's probably still staying at about the same level, but it's still breaking off. There's so many different things that happens with them. It's just depending on what the different circumstances are. Okay, know the difference between a valley formed by rivers and streams and one formed by glaciers. What do you think would be the difference? In most cases, if you have a valley formed by a glacier, it's more U-shaped. If it's formed by a stream, it's more of a V. And one way to think about that is that glacier's going through, it's not eroding everything at a knife edge shape and a point on the bottom. It's got a rounded bottom on it. So it's moving it and, you know, tearing everything out in a U shape. A river, as it's eroding, if you've ever saw a stream at the beach or something coming out, as it moves the sand, it just wants to cut straight down. It doesn't cut a V shape or a U shape out like this. It's got straighter sides on it, especially toward the bottom. So you have more of a V shape whenever you have one that's formed by a river, instead of the U shape that you have with the valley, glacial. There's the glacial valleys. Let's see. So you see this here, you can see this one has really got the U shape and the rounded valley on the bottom. Let's see, I should have, no, I don't have one of a river really. But I'm sure y'all have all saw pictures of one formed by a river to where it's a real sharp pointed bottom and it's more V-shaped. But like I say, you can really see the U shape on this picture. Okay, describe the two main ways glaciers move. We've done talked about some of that. But the two ways are plastic flow and basal slip. The plastic flow occurs whenever it occurs about 150 meters below the surface of the glacier. Basically, the high pressure causes the ice to be more fluid, and the plasticity one. I deal with dirt a lot, so if we get a dirt that's more of a clay and is real slippery, we say that's more of a plastic type material. You know, most of your plastics are slippery. When a plastic is melted some, it moves real easily and stuff. So that's what this does. Now on the basal slip, that's where the glacier melts and the water actually is what lubricates it, makes it go easier. So one of them is the glacier the ice itself gets a little bit more fluidy and slippery and makes it go. The other one is it's got a layer of water basically up underneath it that is allowing it to slip. And water doesn't necessarily make you think of a lubricant a whole lot because it's not slippery like oil, but it'll sure make a car hydroplane in a heartbeat if you get much up underneath the tires. Water does some weird things when it gets in certain situations. Okay, so draw, photograph, model, or describe the following landforms on a glacier. So like I say, there is an empty page in the back if y'all want to draw some of this stuff. Amy, you gonna pronounce that one? Right there. Arit. I don't know what the little stuff like that means on them. All right. Okay. So it's a sharp, jagged peak that separates two glaciers, or a cirque. So let's see if I've got. So it would be something similar to like this little peak right here. Because you see you've got a glacier right here, and you've got a cirque glacier right here, and you have a little peak that's in between it. If you'll look at some of the other pictures a little further on, I think there's some of those. So here you have a cirque here also. And the cirque is a little bowl-shaped depression where the glacier will actually carve out and creates a little bowl in the side of a mountain. And it can create a lake and things like that later on. So here's the horn. Here's the Arit. You see right there, that's kind of more of a ridge there instead of just a point. And then you have a col. And it is a low point or pass. So you see this is more of almost a valley or a low point in the Arit, or the ridge that's been formed through erosion. And you can see here you have glaciers all over. This is really pretty, but I don't think I'd want to hike through it. I bet you'd freeze like crazy with all that ice. I love to look at snow, but I don't think I would last too long living somewhere where there's that much snow. I guess you would get used to it after a while and you'd learn how to deal with it, but it's not something that I'd like to do. Okay, a drumlin. It's a tear or inverted half canoe-shaped ridge of debris. So let's see, right in here, you see it kind of looks like a canoe. They're sticking up and not going down. So the glacier kind of shapes it as it moves the direction that it's headed toward. And then whenever it recedes, it leaves these little long hills that look a lot like a canoe or something like that. It said the head end or the end toward the glacier is often flattened, and the other end is often steep. Okay, esker. It's a steep-sided meandering ridge formed by a subglacial or, well, basically a stream. You can see right here. And this is an actual ridge, so it wouldn't be cut into it. But, you know, basically what might happen on something like this is the glacier is flat on the bottom, but you have a stream going through it. Well, it's actually, as that water is melting, it's carrying sediment out of there. Well, as it's going through that glacier, that sediment's building up in that stream. So when the glacier melts, it leaves a raised stream bed up that's higher than everything else around it. It's not what we expect to see in a normal erosion feature, because normally when you have a stream going through it, it cuts into the ground. But this one, because you have ice on each side of it, it builds the ground up, and then when the ice melts, it leaves a raised bed. Glaciers do some different formations and stuff like that. It's kind of different how they do. Okay, a ford. They have valleys or just formations, and I think I've got some other pictures of them later on, but you'll see a lot of fords that are like a very deep valley. You get over in the Scandinavian countries, they have a lot of these. They have long lakes and stuff, and they're very, very deep lakes. And they're very cold lakes. Not only are they cold because where they're from, they were formed by glaciers and stuff, but it's so deep, the water in the bottom of that thing stays cold all the time. But it's a U-shaped valley formed by glaciers, and it extends into water below sea level. Okay, glacial horn. is the top point that sticks out of some mountains and different things from where the mountains were ate off by the glaciers. So if all this was formed by glaciers, think of how thick that glacier must have been to be over the top of those mountains to be able to erode all that stuff away. It's hard to think of glaciers that many thousand feet thick, but at one time they were there because we see the evidence of what they've done. So it forms when 3 or more cirques intersect, shaping a pyramidal mountain peak. So think of the Matterhorn. And I'm sure they're not talking about the ride at Disney. Have a cane. You see these right here, these are just little mounds that it leaves as it's receding. They're basically deposits of gravel that were left as the water flowing over the glacier. It just kind of left and deposited there. Nunatak. It's a mountain peak that protrudes through a glacier or through where 2 or more glaciers meet. So you can see like right here would be one because it's going through a glacier. Did I have another picture? No, that was it. Like I say, that's right there. It's coming up through the glacier. And you'll see other ones in other pictures and other things when you look at the different glaciers. It's just basically one area that's higher than the glacier, so it's still sticking out. Okay, you have an outwash fan. Outwash fan, it's an alluvial plain, which if you've ever took the geology honor, you'll learn about that. But basically, as it washes all this sand out, it deposits the sand out in this area as the water slows down and the sand falls out of it. And it just builds up more and more. And it'll just create a big fan out in the ocean, river, or whatever it is. That's what an alluvial fan is. So it's a fan, alluvial fan, that's created by the debris that comes out of the glacier as the glacier melts. And it's amazing the amount of sediments and stuff that come out of these things. But you figure, like that one earlier, I think it said it was 121 miles long. No telling how wide. Think of it grinding across the ground and just tearing all the dirt and the rock and everything all to pieces. You have a lot of sediments that are left over. Pronounce that one for me, Amy. What she said. It's the term for an elongated, round knob of bedrock shaped by a moving glacier. So if you just want to put an elongated round knob of bedrock, that's fine. But you can see the glacier, instead of tearing it completely off, it just kind of erodes it to a point. I guess if it kept going long enough, it would probably wear everything down smooth. But it's just some features that it leaves there until nature takes its course long enough. It says that it's formed by the glacial till rather than carved out of the bedrock. So I guess what it's saying is this is the glacial till, or the sediments that it's leaving behind, is what it's made out of. Steration, basically you can see the steration here in the rocks to where the glacier has moved over and it's just scratched the rocks and scoured stuff out all to pieces. So basically, excuse me, it's just groove lines that are carved into the rock. If you have a nice clean piece of concrete and you take a rock and go over it, it scratches it. Well, imagine that by 1,000,000 times, because that's about what it's doing. You don't think of ice being hard enough to scratch rock, but the weight and everything that it is, it'll tear it all to pieces. It grinds everything down to just pure dirt and sand. trim line. The trim line is basically the boundary in between where the glacier was and where it was not. You can see everything here has basically been kind of ground off more smooth, to where this here has the more features were just from the erosion of water and different things over the years. And you can kind of see here too some of the styration and stuff from where that glacier was at one point. Like I say, they'll eat about anything, including the mountain, all to pieces. Okay, so what is a moraine? Name and describe 3 types of moraine. They're basically mounds of rock and sand and debris that's left. So you have a terminal moraine right here. So basically what happens, that's where the glacier ends. That's where everything melts, and when it melts, it drops all the sands and rock that it's been holding the ice, and it just leaves a pile of rock right there at the end. You also can get a recessional moraine, and that is where, as it's backing up, it drops the rocks and the sands and stuff like that. And let's see. You get a lateral moraine, and that's formed along the edge of the glacier from falling debris. So I think it's probably more along the edges. You'll get some things like that that are falling off the side or even falling from the sides. And as it's eroding the valley walls, you'll get a lateral moraine on that side too. As it's eating the walls, the things are kind of falling down and the stuff stays along that edge. Because it wouldn't pull it into the center because you're dealing with ice, not water. So that's the 3 different types. You have the terminal, the lateral, and the recessional, excuse me. So medial moraine, which runs parallel to the glacier, but forms where the 2 glaciers merge. So you have that too, which we already covered this. But the recessional forms along the smaller accumulations on the terminal. So this would be a medial one right here, where 2 glaciers went together, and it just kind of filled in from stuff dropping off the edges of both of them. Let's see, and here's just some more pictures of some different ones. Okay, they want us to talk about safety. Now, what's some good safety rules if you're on a glacier? What would be different from just hiking a trail down here? Yeah, like we were talking about earlier, it'd be good to have a couple of people and tie off to each other. Because if nothing else, on ice, if you fall down and you're on a slope, you're probably not going to stay where you were. So hopefully you got enough people where if you fall down, you won't pull them with you. Yep, it's like he's saying, a lot of the shoes that they walk on things like this, you can see a little bit right there, they have spikes on them because that helps keep you from slipping and moving all over the place. Has any of y'all ever walked on ice? It's not real easy, is it? If you ever get a chance to go ice skating, see if they'll let you just walk on there with your shoes. See how well you do. I mean, I've seen people that do it, that are used to doing it all the time, but I know the first couple of times I've walked on frozen ponds and stuff, it did not go well. You do good for the first couple of feet, and then you start getting a little bit more confident, and you end up busting your behind. So, you know, some safety rules on this sign that, you know, is kind of common sense to me. No swimming. I don't think I want to be swimming in the glacial lakes and in the glacial streams, especially not without a wetsuit, because it's going to be cold. You know, you see these things he's got. If you're going to be climbing on them, they actually have things with hooks on them that you can put into the ice to give you a handhold. Now, something they're doing here is they're kind of demonstrating to where if you get stranded out there on that ice sheet, you can actually make you a little hut inside the snow to stay warm. And that's never really made sense of you get inside of ice to stay warmer. But they said it will amaze you in an igloo or even something like that, how much warmer it is inside of there just from your body heat versus being outside there where you have winds and stuff blowing. I know a lot of times they'll take a little stove or something like that and put in there, and it'll bring the temperature up drastically. Maybe not to the point you're comfortable, but if it's 50 degrees warmer inside there, you know, if it's negative outside and you can get to where you're 20 degrees or 30 degrees in there, it makes a big difference. You don't think about it, but how about the little staffs right there that they have? It's amazing how easily you slip on stuff like that. And a lot of the places on the glaciers, you don't have nothing to grab onto. So if you slip, you're down on the floor, on the ground. And for some reason, when you're in ice, it is so much easier to mess around and hit your fingers and bend them backwards or twist your ankle or something like that versus being on solid ground. So it's just a lot more chance of injuries. Good idea to let people know you're out there. You don't need to be on places like that by yourself. That way, if you overdo, they can come look for you. So just a lot of things to think about before you ever go take a hike on that. So glacial troughs and U-shaped valleys. This is evidence that glaciers have disappeared and can still be seen all over the world. So from a biblical viewpoint, discuss with your class how these might have been formed. So we see valleys that look like they come from glaciers. Where do we think these glaciers came from? What's that? The flood. Why did we have glaciers? Why was that tied? Why did the flood create glaciers? Yeah, imagine the whole earth being covered with water. You had so much volcanic activity. You had a lot of particulates like ash and stuff up in the air. As the water dried, with that particulates up there in the air and you had warm water, the warm water evaporated. But you had a colder atmosphere because all the ash was blocking the sun from coming in. So you had colder climate for a long time after the flood. And you had a lot of snow in these higher elevations, and that created all these glaciers. And the sea level, I've heard, was probably 400 to 900 feet lower than it is today. They have actually found some civilizations that were built at almost 900 foot below the sea level we have today. I know I've heard if you go out in the Gulf, here off the coast of Florida, you can go miles out, but they have found settlements out there. So they know the water level was a lot lower back then. And this is where a lot of that water was. It was in all these glaciers that happened after the flood. Now, regular science will tell you this happened over millions of years, that the ice, only builds up a couple of inches every year. Well, there was a plane that crash landed in one of the glaciers over in, it was one of the Scandinavian countries, I think, in World War II. They just brought the plane back up because since it was encased in ice, it was preserved perfect except for the belly landing they did. So, trying to remember, it was under 90 or 100 foot of ice in less than 100 years. So they brought the plane back up, they restored it, and they're flying it. So it's real interesting, things like that. I think I might even have some pictures on this because they were talking about some different things like that. When something's caught in the glacier, it is often preserved like a time capsule for decades, even hundreds of years, giving us a great opportunity to study the past. Creatively present one of these discoveries to your group. So that's something that it would be good if y'all did a little studying on what they find. So we'll go over some of the different things you can find. This is one of the ice cores that I was talking about that they do. And they'll bore in those glaciers hundreds of feet deep. The only problem is if they figure their thing of 1 inch to the 100 years, they'll be way off on their dates of where it came from. But it gives us a clue of how things were in the past. Like I say, from the different layers of snow, you could find all kind of different chemicals from the air bubbles that were trapped and different things like that. You can even tell a lot of the type of climates you had. They have found a lot of pollen in some of it, showing that you had a warmer climate that had a lot of plants blooming and things like that. They find ash from volcanoes. They can find remnants of smoke to where maybe you had large fires and different things like that. So it's really interesting what they can find. This is the plain I was talking about. Let's see. Well, I was wrong. It was under 250 to 300 foot of ice. And that was 50 years after it was done. So that showed, that it did not take that long for that amount of ice to accumulate over top of that plain. This is an ice min. They found it was still frozen in the glacier. And they have found a lot of dead bodies of animals and people that were frozen. I think I saw the other day they had found a Viking sword or something from where it had melted. And they found that sword in the glacier, and it was still preserved almost perfect. It's real interesting how well the ice preserves things. So that's something y'all can do, is do a little bit of studying on that and get with your director, tell them what you've discovered about how glaciers preserve things and the different things we can find in glaciers, because it's kind of like a time capsule. Then you're supposed to do 2 of these following: visit a glacier or a place where glaciation has happened, and discuss with your group or write a 200-word report about what you saw. So those of y'all that went to Glacier, y'all have probably already done this, because y'all probably talked about it as y'all were leaving the glacier and as you were seeing it as you were driving through it. Watch a video about a glacier and discuss with your group and write it's cut off, but write a report on that about what you learned. Or you can draw or paint a picture about something you had fun about learning while studying about glaciers. Or talk with the group or write or make a short video about a real glacier study or conservation project. So this glacier here, you can see the elevation of how it goes down. It's pretty good size. You can see right here where it's starting to break off, but you can kind of see a line and some stuff where this glacier must have been way down here. You can see where it kind of left a little bit of a lake, but it leaves a flat bottom for the most part, a smooth bottom as it goes. Okay, so that's the honor. Did y'all learn anything new about glaciers? I hope it stays with you. I know some of this stuff can be boring, but it is interesting. I hope y'all got something out of this. But y'all want to take a break for a few minutes now? Okay, 15-minute break then. Yes. Okay, that's fine.